Hello everyone, I'm Mark Tewksbury, your host for this program. Our goal is to reveal to you the methods and materials that turn out the products you see around you every day. If you think you know everything about these items, you're in for some surprises. There's a whole new world waiting for us to discover here on how it's made. Today's topics: kayaks, safety boots, cereal, and electronic signs. It's a therapeutic deadly poison. Seems contradictory, but that's the case with certain snake venoms used in homeopathic medicine. Several years ago, they discovered snake venom was an excellent anticoagulant. The cobra's, for instance, has analgesic properties and is very useful in treating certain tumors. Who knew? In days gone by, kayaks were used primarily for hunting. Now, modern-day kayaks are marvels of molded plastic available for all sport enthusiasts. A kayak is formed by the melting of plastic on a mold of nickel. This mold is made in two parts, an upper and a lower section. The surface of the mold is perfectly smooth and has a mirror finish that guarantees an excellent luster. The graphics are laid on the mold before molding begins. This way they're well impregnated in the plastic. It's an operation that requires quite some dexterity because, contrary to self-adhering stickers, these graphics can't be lifted off if they haven't been well positioned. This is the yellow powder they're going to melt, linear polyethylene. It comes in several colors. The amount of powder to be melted is determined by the kayak model to be made. At the same time, in other molds, they're going to fabricate other parts of the kayak, such as the baggage compartment cover, the central support, and seats. The polyethylene is poured into the mold, which is then closed. All the other molds are closed as well. Before entering the oven, the molds are securely closed with clamps to avoid any loss of polyethylene. The kayak mold is put on a transporter and placed facing the oven. Because of the large dimensions of the craft, the oven has to be custom made. The whole kayak goes in. The oven is 7 meters long and has a diameter of 1.7 meters. The polyethylene melts at 288 degrees centigrade. To completely distribute the powder throughout the mold, it pivots on several axes. It turns on itself while the oven oscillates 30 degrees towards the front and rear. This procedure is termed rock and roll and lasts 19 minutes. Cooking is now over and the mold exits the oven, but the plastic has to cool in order to solidify. To do this, they place the mold in this cooling chamber. It must not be cooled too quickly or it deforms. A 4.8 meter kayak can lose up to 15 centimeters of its length. Now the cover of the mold is lifted off. Then they unmold the cover and the other small parts. The kayak is finally unmolded. Now they can proceed to machining it. While inspecting the kayak, they remove any plastic ridges left by the joint between the two halves of the mold. They now move to finishing. This begins with the screwing on of carrying handles. Here they cut the opening for the baggage compartment, and then they install the trimming. The central support is positioned. It plays an important role because it links the bottom and top portions of the craft. All that remains to be done now is to finish the baggage compartment. They attach fasteners, then put the cover in place and hold it down with a retaining strap. Finally, the kayak is packaged, ready for delivery. This company makes 12 kayak models of various dimensions. Drop a hammer or something heavy on the job, you may not be on the job the next day. But if you're wearing a pair of sturdy work boots, chances are you'll be just fine. Work boots are made from cowhide, which has undergone mineral tanning and finishing tanning. A waterproofing treatment completes the preparation. Let's follow the process. This machine is a shaver. It evens up the hide and opens its pores before it receives other appropriate treatments. They treat the hides in this retanning drum. Water, coloring products, and retanning products are at a temperature varying between 32 and 60 degrees centigrade. Hides are then removed from the retanning drum. The leather will then be vacuum dried for 2 minutes at a temperature of 70 degrees. Then the hide will be hung for 24 to 48 hours. Here the hide is stretched on a vacuum drying plate. It's evened out to get rid of any creases. A hide measures almost 2 square meters, and they'll need about 0.4 square meters of leather to make a boot. They begin cutting the boot parts. This punch, with the help of a press, cuts the different pieces of leather. They also cut brown fabric pieces, the interior lining of the boot, made from a foam base and woven polyester fibers. This paring machine thins the edges before they're sewn. During the cutting, each piece of leather is identified by its size. They now begin assembly of the boot. The 2 sides of the boot are sewn together on this machine. Now the front part of the boot is assembled. Excess leather is progressively cut away. The eyelets, made of steel, brass, or aluminum, are then positioned. Here they attach a foot mount on a form with tiny nails called tacks. The last is placed in the boot to facilitate the assembly of the front part. This carding machine removes any unevenness at the level of the lining before proceeding to the next step. They now install the tempered steel toe cap. The lining is pulled, they insert the cap and fix it well in place. The leather is folded beneath the boot, the bottom secured with a tack, and the sides fastened with hot glue on this seat inside lasting machine. The boot front is now finished. We get a good view of the application of the hot glue. At this stage, they remove the last, installed at the beginning. It's no longer needed. Now the sole will be installed. The heel core is of pine. It's put onto the sole, which will soon be secured into place. Here they proceed with machining and welding of the rubber sole to the boot tip. It's called vulcanization, done at a temperature of 165 degrees, and the sole is solidly installed. This machine sands the edges of the sole to eliminate any vulcanization residue. They also apply a sealant. They now place an insole inside the boot. Here they install the laces and stitch on the labels. The boots now leave for the packaging area. Building a pair of boots required no less than 123 different fabrication steps, including packaging. Each pair needs 101 meters of nylon, cotton, and polyester threads, and close to a square meter of thick and rugged leather. You know those big electronic signs with lights, color, animation? Well, this little thing is where it all starts. Digital electronic signboards are sometimes used as giant television screens or to post written messages. They come in different sizes, from a few meters all the way up to several hundreds of square meters. The creation of a sign starts with plans drawn by engineers and architects. Hundreds of plans are created by computer, among other methods, and require between 2 days or even a month of work. Millions of tiny lights, or light-emitting diodes called elements, make up the screen's surface. These elements are made of germanium, gallium nitrate, and silicon semiconductors covered with plastic. These elements have to be placed so as to form a matrix. Each of the 20 machines at this plant can install and solder 1,500 elements an hour. Lighting up an element requires only 10 to 20 milliamperes, and they last for about 150,000 hours. All the wires are placed behind the matrix and the different electrical connections. This conceals everything behind the sign and shelters it from the weather. Depending upon the distance from which the sign will be seen, spaces between the elements vary from 2.5 millimeters to several centimeters. A workman now makes the electrical connections. The wires have to be solidly connected to resist shaking caused by movement of the signboard. The matrices must operate together and require controllers which send information from one to the other. Thus, each group controls its own image. Each matrix has to be electrically powered and integrated to its own 5-volt element illuminating connector. Sometimes the matrices are made in 2 pieces, one supporting the elements and the other having the components. In this case, it simply requires 2 cards to establish the contact. Now they connect the information cable, which lights up and extinguishes the elements. Each matrix has 2 connectors, one which supplies the electric current and the other which carries the sign's information. Here they verify the functioning of each matrix. Then they can begin to join matrices together to construct the signboard. We see here all the colors assembled as they will be on the screen. The boards are sometimes installed outside and are thus vulnerable to the weather. That's why they put on this rubber strip which waterproofs it. The matrices are now assembled together. Then 10 matrices are joined to make up a module. At this stage, they insert the signboard conductor. Then the wires are connected. These wires transmit electric current and all the information relating to the sign. The elements require a very low voltage current, about 5 volts. Each module is then provided with its own converter to maintain a steady voltage. Then all the modules are assembled in the signboard support, and the many electrical connections linking the different modules are made. This gigantic signboard is a composition of 35 modules and 12 matrices. The signboard is almost finished. They now check the color, the luminosity, and the resolution of the screen. The signboard is made of 120,000 electrical light diodes and took nearly 3 months of work. Each year, this company constructs hundreds of digital signboards requiring about 100 million lighting elements. I've never been an early riser, but hey, I've got to eat. So I have a bowl for breakfast, a snack bar on the run. Thankfully, the goodness of cereal comes in many forms. Our breakfast cereals were born out of religious beliefs of the American Seventh-day Adventists, vegetarians, who in 1860 founded a sanatorium where patients were fed only cereals, wheat flakes invented by Dr. John Harvey Kellogg. His brother, William Keith, saw a promising future and built the first flakes factory to market the product, whose success would later be imitated by the famous Charles William Post as Post cereals. The making of frosted corn flakes starts in this cooker. The corn kernels are cooked here for 2 hours and 20 minutes. The corn kernels are then ground up. They're ground up by this endless worm screw. It also determines the number of kilos of kernels needed to make up a cereal recipe. The ground corn is next dried in a dryer unit, an important step before they're cooked. To give them their nice flat shape, the corn kernels are crushed in the flake roller. 2 rollers turn opposite to each other, and the kernels fall into the constricted space between them. The flakes then fall onto this conveyor, and the next step will be cooking. The flakes arrive at the cooking oven. They're shaken to make sure they will be uniformly browned. The flakes exit the oven well browned. Then they fall into this chute and head in the direction of the next step. This vibrating conveyor sorts the flakes and retains only the right-sized ones. This drum mixes the flakes and sprays them with a sweet solution boiling at 230 degrees centigrade. The sweet solution is dried, and a rake uniformly spreads out the frosted flakes on the canvas. Now they add in vitamins. The cereals are placed into this rotating drum. The vitamins are sprayed onto the flakes by a series of jets. The cereals are now finished, and they head toward the packaging site. This packager fills the bags with cereal. It handles between 40 and 45 bags a minute before they head off for final packaging. This plant doesn't only make cereals, it also makes soft cereal bars. This kneader mixes the ingredients, oat flakes, rice, and syrup. The preparation is mixed twice a minute. When well mixed, the preparation is poured into a large container. They will now proceed with the molding of the bars. The contents of the bin are emptied onto a conveyor, and then the preparation is spread out. Here they add chocolate chips to the preparation. The mix is compressed to the desired bar thickness by this roller. The bar separator then divides the mix into 35 equal strips. And then a guillotine cuts the bars to their proper length. The bars continue circulating. This equipment is used to line up the bars and make the packaging process easier. Side by side, the bars are here turned so that they run one behind the other. This roller applies a delicious caramel fondant to the bars. This caramel fondant then cools and sets. They're now at the final stage of production, coating with chocolate. About 180 kilos of chocolate are needed for the bar recipe. Now finished, the bars are ready for packaging. This machine individually bags the bars. Finally, they proceed with the packaging. These tasty bars will be enjoyed by children as well as adults. I hope you enjoyed our show today. We wanted to take you behind the scenes to the world of manufacturing. I'm Mark Tewksbury. See you next time on How It's Made.